Hello, welcome to 5.6. Today we're going to learn about double and half angle formulas. First, we're going to start with proving sine of 2a. Let's see what this equals. Well, the first thing I know I can split it into the sine of a plus a, which is sine a cosine a plus cosine a sine a. And we know this because that's the composite argument property that we just used. Now, these are the same variable, so we could just write this as 2 sine A cosine A, and that right there is our proof from sine 2A to here. We can also do the same thing with cosine of 2A, because that's the cosine of A plus A, which is cosine A cosine A minus sine A sine A, which is cosine squared A minus sine squared A. And that's the end of that proof. Now, cosine 2A equals cosine squared A minus sine squared A, but we know negative sine squared is equal to cosine squared A minus 1 because this is a Pythagorean identity. So we could write this as cosine squared A plus cosine squared A minus 1, which is just going to be 2 cosine squared A minus 1. So this is another formula we could use. There's also another formula, because cosine squared is equal to 1 minus sine squared, so we could substitute that in and say 1 minus sine squared A minus sine squared A is going to equal cosine 2A, which is just 1 minus 2 sine squared A. And that's the end of that. So there's a couple different formulas we can use for cosine of 2A. Tangent of 2A, again, we take tangent of A plus A. Oops. Which, for some reason, I have this written next to it. I guess that makes it easier. I didn't know it was there. So we want to prove that this is true. So if we start with the left-hand side, tangent of 2A is tangent of A plus A, which is tangent of A plus tangent of A, using the composite argument property. And tangent A plus tangent A is 2 tangent A. And this bottom would be tangent times tangent, which is 1 minus tangent squared A. So this is the proof of this original and new identity for tangent. Now the half angle properties, I am not going to go through and show where they come from. We're just going to have to know how to use them, but not where they come from. Alright. Now we want to show numerically that this is true. So let's pick some value. Let's pick A is equal to 300. So the sine of 1/2 of 300 is equal to plus or minus the square root of 1/2 times 1 minus cosine of 300. Let's move some of this down. Now that's going to be the sine of 150. It's going to equal plus or minus the square root. Now cosine of 300, it's nice because we can use our exact values. It's going to be 1 over 2. So that's 1/2 of 1 minus 1/2, which is also half. So that's going to be plus or minus the square root of 1/4. And if I square root that, that'll just be 1/2. Let's see if that is going to be equal to the sine of 150. So we still have a plus or minus here. Now the sine of 150 is going to be out here, where this is a 30-degree angle, where the opposite is 1 and the hypotenuse is 2. So the sine of 150 is 1/2. Now this thing that I'm moving down, it's in red, is supposed to be here to remind us that, see how this right-hand side is saying plus or minus 1/2? It's not saying that it's both. It's actually, you have to figure out whether it's one or the other. And how we figure that out is we figure out which quadrant this is, the half angle is going to be. So the sine of half of A has to be, if this is going to be here, it's going to be in this part there. So, so we know that the sign in quadrant 2 is always positive. So in this case, we drop the plus or minus, and it will just be the positive side to that. All right. So in this problem, we're saying the sine of A equals negative 3/5. Find the value, or for the A between 180 and 270. So between 180 and 270, we know A is here. So A is this angle, where the opposite side is 3 or negative 3 if we're counting direction. The hypotenuse is 5. So if we expand using the sine of half A, that's this formula here, which is plus or minus 1/2 1 minus cosine theta. So plus or minus square root 1/2 1 minus cosine of A. Just want to make sure, yep, you got that one right. And so the cosine at A is going to be, if this is a 3, 4, 5 triangle, so that'll be negative 4/5. So that's going to be 1/2 1 minus negative 4/5. If I add those together, that's going to be plus or minus 1/2. 1 plus 4/5 is, 1 is 5/5, so that's going to be 9/5. So 1/2 times 9/5 is going to be plus or minus the square root of 9/10. And now let's check and see. If I take half of this angle, you can pick, let's pick any number between 180 and 270. Let's say 200 or 250. If I take half of that angle, it's going to be up here. Up here is sine positive or negative, and that answer is positive. Quadrant 2, the opposite side is always positive, the hypotenuse is always positive. So this answer will be positive, and so it'll be the square root of 9/10, which we could simplify to be 3 over root 10, which simplifies to 3 root 10 over 10. Now, we wouldn't get, it wouldn't be awful if you just left it like that, but this is a rationalized denominator. All right, so if I wanted to find the cosine of 2A, now the cosine of 2A, we can use any formula. If we go back up here, we have 1, 2, and 3 formulas. So let's, we can pick any one. Let's do 1 minus 2 sine squared. So 1 minus 2 sine squared A. So sine squared A would be 1 minus 2 negative 3/5 squared, which is 1 minus 2 9/25, which is 1 minus 18/25, which 1 is 25/25, minus 18/25, which is going to be 7/25. So that is my value for the cosine of 2A. Notice how we found all of those values without using a calculator. Alright, so what's the sine of 2A? So the sine of 2A, if we look up here, sine of 2A is 2 sine A cosine A. So, right, 2 sine A cosine A. Well, if cosine of A is 5/13 between 270 and 360, That means my opposite side is 12. So 2 times 12/13 times the cosine. Oh, and this should be a negative 12 because it's going down. Times 5/13. So that's going to be 10. So that's negative 120 over 169. And that's going to be my sine of 2a. If I find the cosine of 1/2 a, that's going to be 1/2 times 1 plus cosine a square root. So we'll have and then there's a plus or minus out in front. We know cosine A is 5/13. So 1/2 times 1 plus 5/13. And so that's 13/13. So it's going to be 18/13 times 1/2, which is 18/26. Which is going to be 9/13. Which, let's look and see if this is going to be positive or negative. So in this quadrant, I could take any number, say 300, divide that by 2, and I get 150. 150 is going to be over here. So if I have 150, is that cosine going to be positive or negative? Hopefully you're saying negative because the adjacent is going to be negative over the hypotenuse. So this answer will be negative root 9/13. And if we want, we can rationalize the denominator to be negative 3 root 13 over 13, but this would be an acceptable answer also. Alright, now this gets a little tricky. We want to solve this equation. Now what does this look like? The only thing that looks similar would be the 2 sine theta cosine theta. So that would be 2. Now sine theta cosine theta is right here, I believe, which is sine of 2a. So 2 times the sine of 2a, or 2 theta I should say, is equal to negative root 2. So I divide by 2 on both sides, so I have the sine of 2 theta is equal to negative root 2 over 2. Now I take the arc cosine of both sides, so 2 theta equals the arc cosine, arc sine of negative root 2 over 2. And what that is it's 2 theta equals the inverse sine of negative root 2 over 2 plus 360n. 2 theta equals 180 minus the inverse sine of negative root 2 over 2 plus 360n. Inverse sine of negative root 2 over 2 has to be down here, so it's going to be negative 45. So 2 theta equals negative 45 plus 360n. 2 theta equals 180 minus negative 45, which would be 225 plus 360n. If I divide by 2 on both sides, this would be negative 22.5 plus 180n. If I divide by 2 on both sides, that would be 112.5 plus 360n. So those would be my general solutions. Between 0 and 360, I would have 112.5. This would be 157.5. And then if I add 180, I forgot to make this 180. I forgot to divide by 2. That would have been a mistake. Hopefully you guys were screaming at the your computer as I was doing that. Now, if I add 180 to this, I'll get 292.5, and 180 to this, I will get 337.5. Those are my 4 answers between 0 and 360. The next problem, 2 cosine squared a minus 1 equals root 3 over 2. So 2 cosine squared a minus 1. Where do we see a 2 cosine squared a minus 1? Well, we have 2 cosine squared minus 1 equals 2a. So let's use that. So if this equals cosine of 2a equals root 3 over 2, now we just do the arc cosine of both sides. So 2a equals the arc cosine of root 3 over 2. Arc cosine is the plus or minus the inverse cosine, root 3 over 2 plus 360n. Got to keep this 2a chugging along here. Now the inverse cosine of root 3 over 2 is going to be root 3 over 2. So that's going to be a 30-degree angle. So if I divide by 2, it'd be 15 plus 180. So all my values for a between 0 and 360, well, I have 15 and 195. And then negative 15 would give us 165. Add 180 to that, it would be 345. And those are my 4 values between 0 and 360. That's what it said, right? Yep, 0 and 360. Wonderful. All right. Now we have this function. 2 times 1 minus, or square root of 1/2 times 1 minus cosine of x minus 1 equals 0. So first, let's take a look and see what we can do with this. 1/2 times 1 minus cosine x. That is going to be right here, sine of 1/2 a. So this is going to be 2 sine of 1/2, I should say x here, minus 1 equals 0. So if I add 1, divide by 2 on both sides, so the sine of 1/2 x equals 1/2. Now I take the arc sine of both sides. And the arc sine is going to be inverse sine of 1/2 plus 360n. And 180 minus the inverse sine of 1/2. I forgot my inverse up there. Plus 360n. So inverse sine of 1/2. Opposite is 1, hypotenuse is 2. That's a 30-degree angle. And so 180 minus 30 is 150. I forgot my x at some point here. Just throwing in my x's. Now if to get rid of the 1/2, I have to multiply it by 2. So this is going to be 60 plus 720n. And I just noticed that I'm dealing with x's, so I should be in radians. So luckily I showed my work real nice here. So I can just get rid of a couple things. My pi over 6's replace my 30 degrees. And if I multiply that by 2, that'll be 2 pi over 6, which is pi over 3. And that'll be plus 4 pi n. Alright, and over here we'd have pi minus pi over 6, which is 5 pi over 6. If I multiply by 2, that would be 10 pi over 6, which is 5 pi over 3. Now plus 4 pi n. So my values are going to be pi over 3 and 5 pi over 3. Alright, well hopefully that helps you get through the homework. Here's your homework, and good luck.